And welcome to section 101.2, Boot the System. Now, of course, I don't mean you should get on your kicking shoes and give the system what it probably deserves. No, we're going to talk about how your Linux system actually boots up. We're going to talk about a couple things. We're going to talk about the BIOS, then the bootloader. The bootloader will load the kernel. We're going to look at dmessage, which, well, we're going to talk more about later, but it gives us some important information about the running kernel. Where the log files, like var log messages, where that's kept and what's contained in there, and then what init means and what we mean by init levels. So let's go through the process. It's going to be a little bit different on different systems, but for the majority of the stuff we're covering here, it's going to be the same on most systems without a whole lot of variation. And more importantly, this is the kind of stuff that you're going to be tested on in the LPIC exam. Alright, first thing we're going to do is when it boots up, go into BIOS, which for me means press F2. So press F2 and we'll see the BIOS. Now this is going to look a little bit different depending on what kind of computer you have. This is actually a virtual machine, but it still has a full-blown BIOS. Now for the boot up process, what we're going to look at, these are the orders in which things boot. Here we have removable devices first, which would be like a floppy disk, etc., etc., then CD-ROM, then hard drive, then network. Now you can rearrange these. If you look over on the right-hand side there's a bunch of options for how to change these. So like pressing up and down, or plus and minus in my particular thing can move this. So I want to boot to the network first, I can put that on top, or I actually like the order that it's in now, and so I'm going to stick with that. Change that boot order, and then the next time you reboot your computer, or usually just when you actually escape and save your changes, it's going to, let's see, save changes, or exit saving changes, and it should boot from, if there's no CD-ROM, then boot right to the hard drive, which is actually what we're going to see here. It restarts, and we should boot directly from the hard drive. Sure enough. So that's how the BIOS is edited. Okay, so now I've restarted the system, and what we have here, now instead of letting it boot up, I pressed escape, and this is going to get us into the bootloader. Now in Linux, there's two basic bootloaders that are used. There's Lilo, or Lilo, L-I-L-O, that stands for Linux Loader, and then there's Grub, or the Grand Unified Bootloader. Now, Grub is the most commonly used, and that's what we're looking at right here. So let's look at Grub right now, and I'll show you some of the things you can do. Now, I pressed escape to get into the menu, and basically we have these three different options for what we want to boot. The generic kernel for Ubuntu, recovery mode, and then memtest. Now, memtest literally does that. It tests your memory for you, so it's a convenient thing to do with a new system. But what I want to do is show you how you can edit some of the menu entries inside here. So I'll highlight the first default setting, and I'll press E to edit it. And inside here, you'll see a bunch of different lines. Now, the top line, this UUID means the Universally Unique Identifier, and that long string of numbers and letters on the top there tells it which hard drive to boot from. Okay, now this doesn't have to be a UUID. This can also say something like HD 0,0 in parentheses, and what that's going to say is instead of UUID, it will just say root and then HD 0,0 in parentheses, and that would show that it's the first hard drive, the first partition. But this is just specifying the first hard drive by device type, which we're going to talk about in several sessions down the road. But just know that that's pointing to the first hard drive. The next line here tells the system what kernel to boot from, and it's located, and where it's located, basically. Since we have the /boot vmlinux-2.6.28-11-generic, we're saying that vmlinux file is the kernel that it needs to boot, and it's located inside a boot directory of that hard drive identified by the UUID. And then you'll see that it says that UUID again. It's telling the kernel itself. Now the first line tells Grub where to look for the kernel. The second line where that says root equals UUID, that's telling the kernel where its root directory is going to be located. Again, it's using that UUID. Now I'm going to press E because you'll see the arrow at the edge. It goes off the screen. So I'm going to edit this. So I'll press E, and this gives us the whole line. Now we can scroll all the way back and see this is the whole line. And basically what I want to show you is at the end of that root directory, it also has a couple other things. It says to mount that kernel read-only, that R0, and then quiet and splash are two different things. Quiet means don't tell us as much stuff as you're booting up, and splash means give us a nice graphical looking boot thing so that we don't have to look at the text flying by. But I'm going to press enter because I want to get rid of those to show you the difference. Now you saw that GUI Ubuntu logo the last time we booted up, but this time you're going to see that if you remove those splash and quiet things, you'll get to see all the debugging stuff as it goes by. Now this next line is the initrd, or the initial RAM disk. Now this is how the kernel loads some tools that it actually needs to get itself going. Now, once the system is booted, it doesn't use the initrd, it uses the programs installed on the hard drive. But it has to use this initial RAM disk in order to get to that point, to load device drivers and mount appropriate partitions, etc., etc. So this initial RAM disk is another file located in the same spot here in the boot directory, and it loads this as a RAM disk, and it just has the tools it needs to finish the boot process. And then this last line is quiet, which again isn't going to give us, it's going to hide a lot of those kernel messages on boot up, and I'm going to delete it. I'm actually going to press D to remove that whole line. All right, so then we just have these 3 lines, and now if I press escape, it's going to forget all these, because Grub doesn't remember any of the things you modify that you change on boot. You have to be in the system to change the Grub menu. So I'm going to press B, and pressing B is going to boot the system based on the changes I've made. So we'll press B, and instead of that GUI Ubuntu logo, you'll see that we have all of this information that it tells us as it's loading. So that's one way you can watch for what's going wrong if your system doesn't work quite right. You'll see what's going wrong because it'll show you the debugging stuff as it goes. Okay, so far we've looked at 2 things. We've looked at the BIOS, and, well, we didn't circle it well, though, did we? We've looked at the BIOS, which stands for Basic Input-Output System, and that's just the computer hardware's way of looking at what boots. And it tells not only how it boots, but what order it boots in. You can also specify other hardware things in there, like what devices are on board and that kind of thing. But for this purpose, we're just going to talk about that's how you specify boot order for like CDs or hard drives. And then we looked at bootloaders. We specifically looked at Grub, but Lilo is also another option. Not as often used anymore, though. So Grub is the bootloader, and it specifies what to boot. It tells the computer, load this kernel, load this RAM disk, and then it goes through the process of actually booting up the computer. And once we're booted into the computer, we can actually look back a little bit at some of the logs and those sort of things that took place while we booted up. So let's look at those logs inside our booted system. Okay, the system is booted up, and we're going to open up a terminal window. Now, inside the terminal window, I want to show you 2 things, and it's very easy to confuse them. Actually, I just had to restart my recording because I confused them. So what we're going to look at is a command called dmesg, D-M-E-S-G. Now, what that does, it gives you a link, or this will show you currently the changes that take place in the memory. And you're going to compare this with an actual file on the computer. We're going to type cat for var log dmesg. Same name as the command we actually just ran, but if we type that out, notice the end here. Pay close attention to what the last few lines are. Bridge firewalling, registered, and then ETH1 link up. If we type this, you'll see that the information about ETH1 is not in this file. Well, what's going on there is the file itself is actually just for the information as it booted up. So what's in the varlog dmesg file is just from when the computer booted up. If you type dmesg, it gives you all the information after that as well. All right, so again, the system booted up right there. It stopped writing to that dmesg file, and now it's going to keep writing to this ring buffer, so to speak, in memory as things happen. So it's really important to know the difference between dmesg and the varlog dmesg. Now, one more place I want to show you that some very useful information is stored is in the varlog messages file. Now, this is going to have a lot of the same stuff. You'll see, oh, look, that's all the same information that we just looked at in the dmesg file. And that's true, but this also adds things from other computers, like the Pulse audio daemon just added into here, doesn't support 4400, blah, 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 blah. So all of this is kind of like the catch-all log place for all the different things, like the kernel log dmessage will go into here, and applications like Apache, or in this case Pulse Audio, they're going to put all of their log information in there as well. So again, var log dmessage is going to be the file that is stored when the computer boots up. To type dmessage, you'll get the more current version as things happen. And then var log messages is kind of a catch-all. That's usually the one that you go to when you're looking for information on problems, or when things are going wrong, or when things are going right, you want to see why they finally went right. So anyway, those are the log files that you can look at to show booting stuff on your Linux system. Okay, so the next thing I'm going to talk about is called init. Now before we do that, I got to talk a little bit about init. See, init is the process that spawns all other processes. It's the very first process that's run when the kernel boots up, and it's the parent process, or the process in charge of all the other processes that run. One way to visualize it is like a big family tree, if you will. Now this command pstree, this is the only thing I've ever used pstree for, but pstree shows this hierarchy of commands. See, init is right here at the very beginning. And then Network Manager, all of these other commands are then child processes of init. And what happens, like, say this accession manager process were to die, or actually, let's go back up further. Let's say, like, this GDM process were to die. All of these things would then become children, direct children of the init process. So it's responsible for starting all these processes and managing them. And then, like, if Network Manager dies, then init would then be the parent of DH Client Network Manager in brackets here. So it's important to know that it's the hierarchy of how it goes, but the buck stops with init. And it's important that you understand init. Now here's the little confusing part. Init, as a process for starting the system, is being replaced in most operating systems. For example, Ubuntu, since, Hardy Heron 8.10, I believe, has been using a new program called Upstart. Now it's a drop-in replacement for init, but it means that the files are going to be slightly different. Same thing with like Red Hat Fedora 11. In fact, if you want to really use the init process or the init system purely, you need to go back to like Red Hat Enterprise Linux 5 or CentOS 5. And why it's still important for us to learn it is really twofold. One, that's what's on the test. So if you're trying to get LPIC certification, you're going to need to learn the init system because it doesn't test on Upstart at all. The other thing is a huge number of servers and things that you will be administering are still running the init system. Like I said, Red Hat Enterprise 5, it's still running the init system. So it's important for us to know it, but you need to know that it's being replaced and you're being tested on this old going out of style kind of program. So anyway, init is the key process that starts everything going, and from there we're going to move on to our next session, our next nugget, and that's going to be about how the init process works, how to switch between run levels, and all of that kind of stuff. Before we move on, though, there's one more thing I want to show you inside the system here. If you go to the boot directory, now do you remember at the very beginning we talked about describing what kernel to boot? I just wanted to show you that this boot directory, there's the root directory and then boot directory. That's where these things fit. Remember we talked about there was the initrd, VM linez. These are the actual files that it's referring to. So this would be, I've actually updated the system since we started, so we have a new kernel as well. But this would be the kernel file that it was referring to. This would be the init RAM disk file that it was talking to. And if we wanted to edit some of the Grub files, we're going to do this later. This is a whole new nugget on configuring the bootloader, but I just wanted to show you where they live. So here are the different config files, like the menu.lst file shows us all the stuff on there. And we're going to talk about, like I said, later on how to configure this. But just so you can correlate like what that UUID and the hard drive and the root directory and everything, so you can see where it fits into the scene here. This is the boot directory and the grub directory inside there. All right, so before we move on to the next session or the next nugget, let's look at what we've done so far. So back here at our original slide, we discussed what BIOS is, what it does, and how to get there. We know that bootloaders are either Grub or Lilo, and what that means. We showed what kernel it is and how it chooses that. We know the difference between dmessage and var log dmessage. A little bit confusing, but it's important to know the difference between those two. And then we showed you var log messages. And last but not least, we talked about init, which is really what we're going to talk about in the next nugget in more depth. But I wanted to point it out this time so that you know that although init is something we have to learn, it's also something that is going away. So you need to know it because it's important, but there's new stuff to learn on the horizon. So I would like to thank you. I hope that this has been informative for you, and I would like to thank you for viewing.